Welcome back, everybody. In this video, we're going to learn how to factor algebraic expressions. Let's get started. When I say factor, some of you may think of different things. For some of you, you may think of problems like this first one written in pink. To factor something out, the greatest common factor perhaps, from each of the following. In part A, notice that both terms in the polynomial have a factor of 9, and they also both have a factor of x squared. So I can sort of pull out that 9x squared, or factor out that 9x squared from both terms. What I'm left over with in the first term would be 2x. If you're unsure how I got that, there are sort of two ways to think about it. One way is that I am dividing each of these terms by the thing I've pulled out. So when I divide by 9x squared, the 18 and 9 cancel and leave me with 2. And I lose 2 copies of x from the top, leaving me with just 1 left over in the top. The other way to think about it is if I make a factor tree for 18x cubed, I have 9 times 2 times x times x times x. And I'm borrowing the 9 and 2 of the x's. What am I left over with? 2x. Using that same idea, when I pull 9x squared out of the second term, I have a 3 left over from the 27, but I'm borrowing all of the factors of x. So I just have the 3 left over. And that would be how I factor part A. Why don't you go ahead and pause the video here to see if you can do part B on your own. The correct answer would be x plus 3 times x squared plus 5. How did we get there? Well, notice that both terms have a factor of x plus 3. So I can borrow it from both of them. The first term leaves me over with just x squared, and the second term leaves me over with just 5. So I'm left over with x squared plus 5 after I factor out the x plus 3. But for others of you, this may not have been what your brain first went to when I talked about factoring. Maybe you were expecting to talk about problems more like these, to factor these polynomials. Now, I have some good news and some bad news with factoring. The good news is they're pretty quick to do once you get the hang of it. The bad news is this is one of those things where practice makes perfect, sort of like your times tables and that sort of thing. I'm going to walk you through the first few of them, but really practicing these problems is what's going to help you get faster at factoring. That said, if you take a look at the additional resources folder on Blackboard, I'm going to put up an extra worksheet if you would like some more practice problems to get the hang of it. For the first one, remember to factor polynomials, in particular these quadratic equations. What I need to do is find multiples of the constant term that add to the linear term. So I need multiples of 6 that add to 5. Let's see what they are. Well, there are only 2 pairs of factors of 6, 1 and 6, and 2 and 3. 1 and 6 certainly don't add to 5, but 2 and 3 do. So these are the factors that I'm looking for. What I get are x plus 2 and x plus 3. And here, it should be pretty quick to check our answer. All I would need to do is FOIL this back out to check if I got the right answer. X times x is x squared plus 3x plus 2x plus 6. And sure enough, I get x squared plus 5x plus 6. So we got the right answer. Why don't you pause the video here, see if you can try part B on your own. Hopefully we were able to come up with the answer x minus 3 times x minus 5. But this one's a little bit tricky because my linear term is negative, the minus 8x piece. And when I look at factors of 15, it's tempting to say, oh, 3 and 5, those add to 8. But I need them to add to negative 8. Luckily, negative 3 and negative 5 are also factors of positive 15. So I can use minus 3 and minus 5, which definitely add to minus 8. Let's try part C together, because now I have a number other than 1 as the coefficient for my leading term. That's my quadratic term. This time I have 3x squared instead of 1x squared. So how do we handle it? Well, we start by looking at factors of 3. Luckily, there's only one pair of factors, 3 and 1. And we're going to stick those guys onto the x's in the resulting binomials we get. So I've got a 3x and a 1x in there instead of just x on both sides. Next, I want to look at factors of negative 2. And there are 2 pairs of factors. There's a 1 and negative 2, or there's negative 1 and 2. But how do I assign them to these spots? Well, this is another one of those areas where practice is going to make perfect. And the more problems you do, the more you're going to be able to sort of see the patterns. But let's pretend we don't know how to do this one. Luckily, I don't have too many answers to check. So let's try 1 and minus 2. So if I plug in 1 here and minus 2 here, and I FOIL it out, I get 3x squared minus 6x plus x minus 2, which isn't quite right. Notice I got the opposite of the right answer. That tells me I need to use the other ones, and that the actual answer should be minus 1 and 2. Sure enough, when I check this work, I get 3x squared plus 6x minus x minus 2, which simplifies down to the correct answer. Go ahead and pause the video here to see if you can try part D on your own. The answer that I got was negative 3x plus 4 times negative 2x plus 1. And this one sort of has all the bells and whistles in it. I've got a leading coefficient with multiple sets of factors, and a constant term with multiple sets of factors. And I need them to add together to a linear term that has the opposite sign, right? So it's got all of the pieces to all of the previous problems we had looked at. So here's how I did it. I listed out all my factors of 6 and 4 side by side. And I knew one of them was going to have to be the negative set of factors because I've got a negative number. I noticed that negative 3 times 1 is minus 3, and negative 2 times 4 is minus 8, and those guys add to minus 11. So I knew those were the pair of factors that I was going to have to use. That's where I got negative 3x plus 4 and negative 2x plus 1 from. And sure enough, I checked my work and got the correct answer. Let's move on to the next one. Now, the next problem, part E, has a name. We call this a difference of squares. A difference of squares. Because I've got a perfect square minus another perfect square. Whenever I have a difference of squares, and let me give myself a little bit more room here. Oops. Let me do it the old-fashioned way. Whenever we have a difference of squares, say a squared minus b squared, this factors into a plus b and a minus b. Notice here I don't have the squares, so these are the square roots that show up in the binomials. So when I have x squared minus 100, I get the square root of x squared, which is x, plus the square root of 100, which is 10. x plus 10, x minus 10. See if you can use this difference of squares formula on the next difference of squares, part F. Hopefully we were all at least able to get x squared minus 5 times x squared plus 5, but, and let me move my head out of the way, we also have another difference of squares that shows up here, the x squared minus 5. I can factor that one further into x minus root 5 and x plus root 5. In part G, though, we've got a whole different thing going on. And this is what we call a difference of cubes. A difference of cubes. There's a formula that goes with these. When I have, and I'll write this in gray here, a cubed plus or minus b cubed. This factors into a plus or minus b times a squared minus or plus ab plus b squared. Here's what I mean by the plus or minus, minus or plus thing. Whatever the sign is here, it's the opposite one here. But this one's always a plus. And there's a mnemonic device to help you remember that. SOAP. Same, opposite, always positive. Same, opposite, always positive. So here, I've got x cubed plus 27. My a in the formula is the cubed root of the first term, or x, and b is the cubed root of the second term, 3. So this guy factors into x, same sign, plus 3, times x squared, opposite sign, minus x times 3, always positive, 9. See if you can use this difference of cubes formula to tackle part H. The correct answer would be 2x minus 5 times 4x squared plus 10x plus 25. Notice the a in my SOAP formula is 2x and the b is 5, because those are the cubed roots of my first and second term. So I write a, same sign, b, times a squared, opposite sign, multiply them together, always positive, b squared. That's going to wrap it up for this video on factoring. Thank you everybody for watching. Catch y'all on the next one.